So reciprocal functions for your syllabus would be solely in terms of reciprocating the y values. Hence, it's 1 over fx. Okay, this something like this is outside of your syllabus, so you don't have to worry about this. Okay. For the sketching of reciprocal functions, right, the gameplay is not to adopt what we went through just now, but rather to ask ourselves the following questions on what will happen to the new function 1 over fx. Okay, so as long as you keep in mind the following questions, right, you won't go wrong. All right. So let's just go down the list. If remember, these things are all on the y values. So if your y is actually positive, 1 over fx, would it be positive or negative? Anyone? Just shout out the answer will do. Okay, yes, hello?
Can you repeat? Can you repeat?
If your fx was positive, right? So 1 over fx, would it be positive or negative right now?
Positive.
Positive, okay, still positive. If it's negative, it will be negative. Okay, so because remember, these things are just transformations on the y values, okay? Y becomes 1 over y. What if the function was increasing? So 2, 3, 4, 5, right? 1 over fx, would it be increasing or decreasing now?
Decreasing.
Decreasing, okay? Because it will become 1 over 2, 1 over 3, 1 over 4, 1 over 5, which is a declining trend. So this will be decreasing. So if fx was decreasing, 1 over fx will be increasing now, okay? Okay, if fx was equals to 0, you will have 1 over 0, right? 1 over 0 is considered undefined, so it's NA. So it will become a vertical asymptote. So you must be watchful for this. If it was a vertical asymptote, it will be equals to 0. Okay, which means that what does this tell us, right? Is that roots become vertical asymptote become roots. Okay. Okay. Then the next thing will be about turning points. If it was a maximum point, which was a turning point of the fx, 1 over fx will now become a minimum point. Okay. If you activate the logic that we have here, you will be able to get the situation. Okay. Then minimum point becomes maximum point then. Okay, understand? Because whatever was increasing becomes decreasing. Whatever that was decreasing becomes increasing. So the logic gets flipped around. Okay, and if the y value was equals to 1 or negative 1, 1 over f will still be equals to 1 or negative 1. And this will be the only two y values where the graph and the reciprocal graph intersect. Okay, because these are the only two y values where post-reciprocal no change at all. Hence, they will intersect. Okay, up to here, any questions in mind? Anyone? No? Okay.
NA.
Okay.
NA means not applicable. Means because it cannot have 1 over 0, right?
Oh.
Means it becomes a vertical asymptote, all right? So if the y values were operating on the range of 1 to infinity, right? Post-reciprocal, it will become 0 to 1, okay? Any values, let's say from 1 to infinity, if you have like, let's say 200 or whatsoever, take the reciprocal, it will become 1 over 200. So it will be between 0 to 1, okay? If you have a y value that was between 0 to 1, let's say 1/3 or 1/2 or 1 over 6, take the reciprocal, it will force you to become 1 to infinity then. Understand?
Wait, what's 1 to infinity?
No, that means any y values that was within this range, right? Post reciprocal, it will become this range. Understand?
Not really.
No. Give me any number from 0 to 1.
0.5.
0.5, you take the reciprocal, it will become?
2.
2. Is 2 inside this interval?
Yeah, it is.
That's what I'm trying to say. Any y value that was between 0 to 1, right? If you take the reciprocal, it will become now between 1 to infinity.
Oh, okay.
Any y value that was between 1 to infinity, you take the reciprocal, the new coordinate will be between 0 to 1. Understand? In terms of the y values. Because this transformation is solely in terms of the y values only. Understand?
Okay, okay.
Understand now? Okay, so with this in place, right, when we ask you to sketch a reciprocal function, the introductory functions tend to be quadratic functions, U-shaped graph or N-shaped graph. So I'll teach you, so these are the guide, these few questions here, right, must be the guiding questions to help you to sketch the reciprocal functions, okay? So you must always start from the roots or the vertical asymptotes first, or ideally start from those things, okay? So -6 and 2 in my black graph here, right, are the roots. So roots here become NA, which is vertical asymptotes. Because -6 and 2 must be excluded from the domain now, undefined. It causes the function to be undefined. So what you will do, right, you will draw two vertical asymptotes right away. Okay, so having these two vertical asymptotes, right, now splits this domain into three partitions, right? Before -6, between -6 to 2, and after 2. Okay, so what you need to do is to sketch these three sections one by one right now. Okay, if you look at the last section from sorry, give me a minute. From 2 onwards, right? Okay, if you look at the black graph, okay, Henry, you tell me, is the black graph positive, negative, increasing, or decreasing?
What was it?
If you
The
focus
black graph?
if you focus on a section here, right, is the black graph
Mhm.
positive, negative, increasing, or decreasing?
Increasing
Increasing and positive, negative?
and positive.
Okay.
Positive.
So with referencing the table, what would the reciprocal graph be like?
Okay, now it becomes decreasing, and then now it becomes, but it's still positive.
So the reciprocal graph must be something that is positive and decreasing, right? Positive and decreasing. So the only logical thing must be this way then. Understand? Hovering around above the x-axis, it cannot reach the x-axis because it cannot be negative or 0. Understand?
Yeah.
Then you focus on the left arm now. The left arm before -6, is it positive, negative, increasing, or decreasing?
Positive, decreasing.
So the reciprocal must be?
The opposite.
Positive and increasing. Cannot say an opposite because opposite means it should be negative.
Oh yeah, positive and increasing.
So it will be like this. Okay, never breaching the vertical asymptote and going towards infinity because the black graph was going towards 0, right? So the reciprocal graph will be going towards infinity. You can see in the same logic in the left and right arm already. Understand so far?
Okay.
Then it's the center portion that is the problem usually. Okay, so the center portion, firstly the y-intercept is -5. So y-intercept can still be derived for the reciprocal graph. It will be -1/5. Okay, so if you have -1/5, then the next point will be here. Okay, so the turning point, previously it was a minimum point. It will now be a maximum point. And this maximum point will be -2, same x coordinate, of course, because the reciprocal function is only applied onto the y values. And then you have -1/7, like this. Agree? Everybody can follow with this?
Yeah.
Okay, so now if you focus on the center portion, right, it's a U-shaped graph. It's not monotonically increasing or decreasing. So if you take into two pieces, this bit here is negative and decreasing, right? So the reciprocal should be negative and increasing. So negative and increasing will be like this. Okay, then if this is done, then you focus on the right arm right now. The right arm is positive, the right arm is negative and increasing. Negative and increasing, take the reciprocal, will be negative and decreasing. So negative and decreasing, and you must pass through the particular y-intercept that I have labeled. So it will be like this. It should be a smooth curve, of course. Okay, sorry for the stylus. So this will be the complete reciprocal graph. Understand?
Yes.
Okay, so by right, this point and this point, their y coordinates must be 1, because it is the only time where the reciprocal and the original graph will intersect on the positive y values. This guy and this guy, their y coordinate must be equal to -1. Okay, the only time when they meet, which is here. Okay, anyone, any questions from how this is derived? Yes, no, yes. Okay, guys, any questions?
Oh, all right.
Okay, so we will go through a few more questions on this. Okay,